Alright, time for another draftphysics.com, debatephysics.com also. But again, the debate isn't rational. There's no rational counter argument. There's just irrational nonsense from crazy fanatics attempting to just deceive and shenanigan their way out of basic arguments. And it's just pretty glaring. So the Ian Gosling has taken my advice and constructed a version of the Brozo experiment, we could call it. I guess it's my experiment, frankly, but whatever. Very simple. Just take the same force, apply it to one side of a lever, and launch things with the other side and see what you get. Now he's launching into gravity, so we know the rules there, that 4 times the height will represent twice the velocity. And it's sort of a strict rule. It doesn't matter what the masses are, it's always velocity is dependent on time. And in gravity, how much time you're spending fighting it and how much time you're spending being pushed by it. So anyway, I guess we just play the video. I don't know. It's just, well, I should draw it first, just to make sure everything's clear. Okay. And what the previous results were, sort of important. I just gotta put that back, and then everything should work, and blah 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 blah. Alright, so really simple experiment. So Brozo's version was a little different. It was done horizontally to get gravity out of the experiment. There's a spring applying a constant force, okay, this consistent force. And in his case, I guess he compressed a spring. Yeah, well, that's my recollection, I guess. Anyway, and so the simple idea is you're going to move the lever to this other position. You're going to have a 2 mass at this location and a 1 mass at this location, one distance away. Alright, and you're going to see if it conserves momentum, which seems kind of obvious that it has to. Law of the lever, blah 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 blah. So this really shouldn't even be a controversial outcome. But because of the kinetic energy theory, they have to argue that yes, the same force has to create the same amount of kinetic energy. So frankly, this can't go twice the velocity. It only can go 1.4 the velocity, because obviously if you square the velocity you end up with way too much energy, kinetic energy, in the two objects. Obviously my prediction is no, this will be twice the velocity. Okay, so it's 2 times 1 and then 2 mass times 1. Same answer, same momentum. This goes 1v. The 2 mass and the 1 mass goes 2v, twice that velocity. And it came out pretty close in Brozo's experiment. This was, let's see, it was 19, so this was a slow one, 19 and 11 in terms of frames to move a distance. So this one only took 11 frames to move the distance. This took 19 frames, indicating a pretty close relationship to, yes, this was twice as slow. Alright, so his version is up in the air. Okay. Spring is this way. Well, it doesn't matter. Okay, so he pushes it down, launches the 2 objects. He has a little notch on here to hold, to stop the objects from sliding, which is good. But they have a big surface area. He's using washers, so their surface area is very large. So obviously this one extends beyond the lever, the point, and so they all flip. So when they travel through the air, they're flipping, moving kind of, and probably not moving straight up. Okay, so there's a couple of defects there. But anyway, the results are exactly, so you got exactly the same result. Alright, so he claims a 1 here, and then he claims this only goes 3, but it's clearly more than 3. Okay, so, and he says because it didn't go, so just like Brozo, so instead of this isn't 20 to 10, and therefore Brozo says it's wrong, and it proves that the momentum didn't work, when no, that's sort of in the margin of error. And in this case, again, the results are way beyond what his theory predicts. His 1.4 theory, taken seriously, says, well, the best you could do is 2.5 in terms of the distance you could expect, and it's well over 3. So clearly no match. So how can he claim that, oh, it didn't come out perfect? Well, it came out pretty close. So I would argue that it's 1, 2, 3. Okay, so we're looking for a 4 and 0.5 at least. Okay, so you got 1 to 3.5, huge. So if I did the experiment myself, I came up with those results, I would publish it and say, yeah, that's a pretty damn good experiment, pretty close. I'd say momentum has been conserved. You've proven that the law of the lever is correct. There's no reason to doubt. Kinetic energy has no hope. Levers destroy the theory of kinetic energy. It's just a fact. They conserve momentum, they conserve energy, and there's no sign of any extra. Okay, so no sign that it takes 25 times the fuel to move something five times as fast, or to spin something 5 times as fast. It doesn't take 25 times the fuel. It's nonsense. Nor does it do 25 times the work. If I make something go 10 miles versus 100 miles an hour, I don't do 100 times the damage. No, it's only 10 times the power. It's only 10 times the force to make something go that fast, and it's only 10 times the force when it does its whatever it's going to do. Now, in this case, you could argue that air resistance matters because he is using flat washers. They are rotating, and obviously light things going fast are going to have more air resistance problems than slow things, heavy things going slow. So the air, the amount of friction from air is going to be much higher. Now, he doesn't understand what friction is. He doesn't understand these concepts. He says, oh, he did the experiment in gravity where there's no friction. Gravity is friction. Gravity absorbs energy. If I throw something in the air, all of its energy is taken from it, and it becomes not moving. Okay, it loses all of its energy, and then the gravitational difference can give it velocity again, back, or not, depending on whether there's a ledge for it to sit on. And when it's on a ledge this high, it weighs the same as when it's on a ledge this high. Same difference. Alright, so I guess we'll just, I could play, at some point playing the whole video, I don't think. But go ahead. I don't hear it. Yeah, so I gotta check my settings. I don't know why this thing starts wrong. It works fine, and then it does something just completely idiotic. And you're saying, why did it change those settings? Just no damn reason for it to do that.
Or bruff.
Ugh, bruffy. Scruffy, bruffy.
Apologies, Steve. Experiment with the lever launched 2 masses. Gary, you claim that was some kind of victory for yourself.
Yes, of course. It was a huge, god damn it. 1911. Yes, it was really close to 2 to 1. And very far from whatever your number is, right? Who the hell knows how they calculate it, right? If you square 1.4, you only get 2, so twice the distance seems, well, that's not happening. And then the other part of their theory, you have to remember they have this wacky theory that I take the same thing, the same object, and I put it on a scale and it weighs 1. And then I take the same exact object and I put it on the scale with it, and all of a sudden now it weighs 4. So somehow this motion is 1, but if I do exactly the same thing from the left-hand side, it's 3. So yeah, what is it? 1.4, so it's 1, and then it's 0.4 of 3, right? So 0.4 of 3 is like 1.2 or something, and so it's 2.2. So he's saying it should have gone 2.2 higher. Clearly didn't happen, and in Brozo's case, clearly didn't happen. Clearly you have way too much energy in the light object. Way too much velocity. It's a lot more than your point 0.4 wacky theory that again is completely annihilates any notion of the 1,000-year-old law of the lever. I mean, this goes back to Archimedes and shit. You know, so you know, these observations about the conservation of quantity of motion. So, you know, fuck you. You're just such a lying sack of shit.
I think you know full well why that result gave a nearly 2-to-1 velocity ratio. I can't remember whether...
So this is, we can't remember, so he doesn't remember anything. And the fact is, I brought up angular momentum. I brought the subject up. And I pointed out, see, this one doesn't rotate, this one does rotate. And I pointed out how, well, yeah, that is a disadvantage to the heavier mass because it obviously has a rotation. Now, clearly you could see in the video, it's not rotating consistent with the motion with the ground. That is, it's rotating way slower than if it was a wheel and making friction. So yes, it's still sliding substantially with a tiny bit of rotation. So, you know, but, you know, that was in the videos. So this liar says I didn't respond to it, or I responded in some way. I didn't respond to it that way. That's a lie. I brought up the subject. I didn't run from it at all. And it's so fucking insignificant in terms of, even if you say there is this angular rotation that's significantly different between the two objects, it can't account for the huge off you are, your numbers. And how almost, you know, 1911, you know, so close.
It was a one mass, one distance, or half mass, two distance, rolling across the glass. One of them didn't roll. It slid.
So they both slid, that's the fact.
Instead of rolling. Which of course immediately can falsify the result.
Says you. So again, you have nothing to say. You don't explain how much the angular rotation would be in the size object it was. You didn't count the rotations. You haven't done anything to substantiate your theory that somehow it rotated so much that half its energy was hidden. It would be half its energy. It'd have to be a lot of energy you had to hide in that rotation.
Because of the lack of energy going into the angular momentum, or rotational kinetic energy, correctly?
There's no rotational kinetic energy, so he just made up a term. There's no rotational kinetic energy. I can't find that on a Wikipedia. Where am I going to find a rotational kinetic energy? No, there's angular momentum, and angular momentum is law of the lever. So you can keep lying about what physics says, but physics doesn't say what you say, you fuckhead. There's no, you know, angular kinetic energy.
And of course this is something that you're very keen to point out in complaining about science experiments with little wheels and...
I should complain. The fact is, these are really important statements physics is making, and the fact that they won't prove any of them just makes it insanely bad science. Why? Well, there's nothing else to call it. They claim something like, well, an 8-pound ball has twice, you know, they're going twice this fast, has twice as much energy. Well, shouldn't they show that somewhere? If you're going to claim that it takes 25 times the fuel to spin a wheel 5 times as fast, shouldn't you prove it somewhere? If you're going to claim a car crashing at 5 times the velocity is 25 times the damage, well, shouldn't you show that somewhere? I mean, fuck you and this fake, phony fraudness of this propaganda. You're just a propagandist, a disgusting propagandist to sit there and say that, oh no, science shouldn't prove anything with evidence. Fuck you.
Angular momentum. And then you conveniently forget it when you're trying to use it to your advantage.
Liar, 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 liar. So again, if anybody goes back to the videos, I brought it up. I explained it. I stated, yeah, it's there, but it's a small amount.
So that was why that result wasn't reliable.
I didn't know originally that he had done the experiment on glass. Obviously, glass isn't a very good friction surface. So obviously, the amount of adhesion to the surface and the capacity of things to actually start rolling is minimal.
You know that very well.
So liar, liar, liar.
And I thought we could do a launching masses into the air. Because we can do away with the friction properly.
So he says things about how he did this, and it's just, you know, it's visually garbage again. He can't, he doesn't tell us how far this piece of paper is from the lever itself, and the closer it is, the better for filming purposes. So they really should fix that huge defect. I mean, they can't do this measurement thing right to save their lives, and it's the most important part of the experiment is the measurement. So, I mean, maybe you should have a string hanging down with little marks on it, and then you can have the string right at the same plane as the lever and know exactly how far something travels. Some kind of way of doing it that would be better than this garbage.
This lever, for balance, I've conveniently...
Okay, it's not a balance because he has the fulcrum through the center. So it won't balance. It won't balance this way. Okay, on a horizontal plane.
That's it for you. We're going to put 2 mass, 1 distance, and 1 mass, 2 distance. With a spring. That's a set stop for the start. And when released, that's the finished position, horizontal, and it will launch into the air. That bottom line is in line with the centre of mass of each weight. Well, that won't appear like it in a minute because of the parallax error.
So somehow he's saying parallax errors, but the camera has to be at some place where it actually is seeing a straight line. So obviously these lines aren't lined up with these lines. And yes, when you view it, he's obviously viewing it from above.
And then we can count the height from that bottom line. 1, 2, 3, and so on. Okay, here we go, the 2 mass 1 distance.
So obviously you can see the parallax. So it has to be being viewed from down because you can see the top of this, the little peg. Can you see all of this? Yeah, you can see all of it. You're close enough anyway. You can see the little top of the peg and all this kind of stuff. And this line, though, really should. These are almost in the same plane. And this stop actually should line up with this line, right? So the bottom of the stop clearly isn't this line. Okay, so that was very fast. Okay, so I gotta turn the speed down. Playback normal. All right, and it doesn't really matter. I mean, for the sake of argument, it's pretty clear. We're going to agree it's close to a 1 for the 1 mass. I mean, the 2 mass. So this experiment. So he isn't using a quick release. So obviously, again, you have the higher velocity. Well, no, it's the same velocity, frankly. So yeah, maybe a quick release doesn't matter in this case because the velocities will be the same. All right, so this one gets launched. All right, and you can see in this case, it's not even going to reach that line. It's not going to reach the first line. I mean, it certainly didn't go over it. Okay. So it didn't rise above it. Yeah, we'll do a few more of this. So, I mean, this is, I'm just saying, it's a pretty dramatic proof of twice the velocity, frankly. And for him to try to pretend it's anything else but showing twice the velocity when he does the other one. I mean, it's such a dramatic difference. So let's see if we, you can't do frame rates because the video is too shitty. Okay, so 3, 4. Yeah, well, time is no good anyway because it takes twice the time to go 4 times the distance. Twice the time coming down. Yeah, not going up. All right. So anyway, let's yeah. So let's get to the 2 mass.
You get a rough idea.
Yeah. Well, they're all below the line, so they never. None of them go above the line.
I think it's going somewhere around this line.
Or a little lower. Certainly not above, I'm just saying.
Okay, the 1 mass 2 distance.
And that has to be the closer to the center of the camera, right? So let's understand the camera's down, so this perspective has to be closer to straight on. But he doesn't tell us any of that, so we don't have any, like, is the whole experiment looking down, or is the camera just down at the bottom and up at the top? So we don't know where the distortions are going to be. And how much those distortions are is completely dependent on how far away your camera is. So the further away, the better.
Is this?
Alright, so this will be obviously quite dramatically faster. Alright, so you can't even see it. Yeah, it's gone. Disappeared. Just can't there. Where is it now? Can't even see it. It is there. Now it's showing up. So it's above the second line. And it's going up to the third line. It's clearly above the third line now. Way above. Substantially above. No doubt about that. Yeah. So 1, 2, 3 point something is a lot more than 1 to 2.5. So you're the one that has to explain, asshole. So again, I'll accept this. I assume I did the experiment and I'm now claiming, see, there's pretty good proof. Now you explain how it's not good proof of twice the velocity. So as you can see, like I said, he is flipping them flat side, which isn't ideal at all. And they do rotate. So these aren't ideal circumstances. It'd be better to have an object, and they are obviously following, they still have some of the arc motion in them. That is, their motion is still, that way instead of straight up.
I think that's going to this line.
It's going over that line. I think clearly over.
Already.
Clearly over.
Sharp-eyed viewers amongst you might have recognised a problem for Gary's theory.
So there's no problem for my theory. This is exactly what the experiment you'd expect it to look like. It looks a lot like Bros. It clearly looks like, oh yeah, that's going twice as fast. It's going a lot faster. No doubt about it.
Gary's theory.
It's not going 0.4 faster. It's going a lot faster.
He says that these two are equivalent.
Yes, and the law of the lever says they're equivalent. Lots of things say obviously the obligation to conserve momentum says they're equivalent. And you're saying otherwise with no references. You're not showing me any physics professor agreeing with what you're claiming.
They are in a static balance. So therefore, with a given
There's static balance. They're not in this experiment anywhere.
acceleration or given force, this one should go at twice the height.
As he said, twice the height. That's an error.
Or twice the velocity.
Yes, exactly. And it's exactly pretty much what you showed happening. So again, just amazing that they can do the experiment, they get a result that's almost perfectly consistent with what I'm arguing, and then claim that somehow it defends their theory when their theory is way off. It's not even close. It's very close to matching my theory, very far from matching theirs. And yet they're claiming victory, which is just too idiotic.
Now if it was going to reach twice the velocity, from this bottom height it has to go 4 times the height. This is 1, this is 2, this is 3.
Right, it went over the 3 line. That's right, so it's getting very close to 4. Very close. Idiot.
There's 1 missing. It's only getting up to 3 times the height.
It says it's more than 3, and more than 3 is frankly a lot more than 2.5 or 2. I don't even know what your prediction is. You have to tell me what your prediction is. How far would 1.4 be?
where's the other height on, Gary?
So again, I could argue that it's air resistance, because twice the velocity, air resistance isn't linear. It gets harder and harder and harder. That's why you have terminal velocity. So the air resistance can get so strong that it stops all possible ability to add energy to an object. So clearly that could have been a factor. And obviously higher velocities are always harder to impose on objects because everything happens in a shorter and shorter period of time. So obviously your launching method isn't perfect. You are rotating the object, you're pushing it too fast on one side, too slow on the other side, you're not evenly moving it, blah 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 blah.
We'll probably say that it's because I've glued together a slop experiment.
Alright, so you've glued together a slop experiment. Now, clearly it's slop, okay? I mean, it's videoed in Sloporama. I mean, the lines don't match. You got lines here, you got lines here. They don't even match. You conceding you have a huge parallax problem. I don't see how it's possible, frankly, that you can say this line is equal to the gravitational center of the washers. Okay, because that's a huge amount of parallax.
But these experiments are indicating no cheating going on.
Okay, I'm just saying he's trying to tell us that this experiment verifies a velocity of 1.4. So only a 0.4 increase in velocity. Do you really think there was only a 0.4 increase in the velocity between those two objects? It's a ludicrous contention. Clearly very close to twice the velocity.
Your theory is obviously wrong.
Okay, I mean, so there's no point in us even having a conversation, right? I mean, if they can distort and pervert evidence this clear. This is like Brozo, 19 to 11. He's saying that's nowhere near 2 to 1. It's nowhere near 2 to 1. Yeah. So how ridiculous. I mean, how far off can they be? So this bar says, really nice construction, Ian. Now I feel inspired to repeat this experiment again. I don't know whether he thinks he did it somewhere, but anyway, obviously it'd be better not to do it in gravity, but no, you really do have to measure these distances accurately. Yeah. It's like fundamental to doing the experiment is having accurate a ruler to do it with. There's just no point in having an inaccurate ruler. But even with it, all right, so even I did a version of this, okay? So I did it with a pendulum. And I did it on my porch, and the result was like this, pretty dramatic. I mean, there was an obvious difference, okay, between the one mass and the two mass. Just obvious. And, you know, ideally it'd be better to do the 3 to 1 mass ratio because the difference will get more and more obvious. Yeah. So anyway, he says this is an obvious victory for his nonsense side, which is just too funny.
The 1 mass 2 distance does not reach twice the velocity.
So we know it's so damn close. I mean, 3 plus and 4. You know.
Otherwise it would go 4 times as high.
And it nearly did.
And this is predicted because of the inertia.
So again, he keeps saying there's this inertia thing. There's no inertia. There's no small objects have more inertia. There is absolutely no evidence that imposing twice the velocity, there's somehow 4 times the inertia. Or if you're trying to go 3 times as fast, there's 9 times the inertia. There's no evidence of that. It's 3 times. 3 times the weight, 3 times the hardness to push it. Okay, it's just this guy is such a liar. You have no physics you're defending here. There's no, like I said, show me the Lewin lecture where this nonsense is defended, you idiot.
The resistance to change in motion according to the accelerating force.
And so again, more nonsense. It's not according to the accelerating force. It's according to its mass. That's the only thing that can stop it from moving, is that you have to put it on the mass. Increase the mass, it's harder to push. Decrease the mass, it's easier to push. I mean, you're just such a liar. All right.
Thanks for watching.
Okay, so when experiments that come out so decidedly against their theory and they're claiming victory, it's just hilarious, to me. I mean, it's just like, can you get more flat Earth? Can you get more disreputable, dishonest, duplicitous? You're just such a liar to say this experiment verified 1/2 mv squared in any way whatsoever. It's nowhere close to showing 1.4 the velocity. Not even close. And it's really close to showing twice the velocity. And you're claiming somehow your theory is vindicated. You have to be just such a liar. You're such an awful human being. Oh, so yeah, do it again. Do it some more ways. Keep doing this experiment. All right. Because it just keeps proving you're liars. So thank you. And such.